Hello everyone, I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU, Varanasi. Let's start the session for today. The first question here in the series RC circuit. Sorry, yes, simply RC circuit connected in series. So in below figure, capacitor has initially charged of 2.5 millicoulomb. At t is equal to 0, the switch is closed and constant voltage source of 100 volt is applied. Then find the current. And the polarity of the initially charged capacitor is also given, plus minus of q naught. This one is a plus, this is a minus. Okay. In this case, you know about the charge q naught is equal to CV. Then you can simply calculate the initial voltage from this one. Q naught is given as 2.5 millicoulomb, 2.5 into 10 to the power of minus 3, and this is equal to CV. Capacitor is 50 micro, it means 50 into 10 to the power of minus 6 into volt. Here you can calculate the voltage. You can say this will be V naught, initial voltage of the capacitor. This will be 2.5 into 10 to the power of minus 3, and then this will be a 50 into 10 to the power of minus 6. This will be 10 to the power of minus 5, so 0.5 into 10 to the power of 2. This will be 50 volt. You can say initial voltage of the capacitor is 50 volt. From this one you can simply calculate the initial voltage. The initial voltage is given, then what is the final voltage? Initial voltage it means this voltage at 0 plus it will be 50 volt. Then what is the voltage at t is equal to infinity? The switch is closed at t is equal to 0. It means at t is equal to infinity, switch is closed and capacitor will be open circuit. This switch is closed, then a resistance is there and the capacitor will be open circuit. This is the capacitor voltage at infinity. But the initial voltage, you can say, if I say this one, if you take this polarity 50 volt, then initial final voltage of this one, this is the positive. The polarity of this capacitor is given according to the question. Is this one plus or this one minus? This is the 100 volt. Then in this case, you can see the negative terminal is connected to the positive terminal of the capacitor, and positive terminal of the negative terminal of the capacitor is connected to positive terminal of the supply. That's why this will be a minus of 100 volt. Then what is the VT? Capacitor voltage. You know, this one is the final voltage plus initial minus final into e to power of minus t by tau. Final voltage is minus of 100 plus initial voltage is 50 volt. This will be minus minus will be positive 100 e to power of minus t by tau. This will be minus of 100 plus 150 e to power of minus t by tau. What is the tau? Tau is equal to RC. Resistance is given is 10 ohm and C is 50 microfarad. 10 ohm into 50 micro. Micro, it means you can say this will be 10 to the power of minus 6 second. This will be 500. It means 5 into 10 to the power of minus 4 second. Okay. We can put the value of this one, minus of 100 plus of 150 e to the power of minus t by tau 5 into 10 to the power of minus 4. This will be 2000 t, because of 1 by 5 into 10 to the power of minus 4. This will be 10,000 divided by 5 is equal to 2000. Okay. Current, you know about the current of the capacitor, C dVc by dt. Because of this this is a simple RC circuit, then current will be flowing like that. C is given as 50 micro, 5 to 10 to the power of minus 6 d by dt, minus of 100 plus 150 e to the power of minus 2000 t. This differentiation of this one is 0, plus this will be 150 into minus of 2000 into e to the power of minus of 2000 t. So 50 into 10 to the power of minus 6, this will be into 150, this will be negative, into 2000 e to the power of minus 2000 t. 2000 into 5, this will be 1 2 3 4 5. 5 into 2 is 10, 6, 10 to the power 6 and 10 to the power, okay, I written it once again. 5 into 2 is 10, then 1 2 3 4 0, 3 4 0 into 150 into 10 to the power of minus e to the power of minus 2000 t. This will be 1 0 2 3 4 5 and this 6 will be cancelled out, minus of 15 e to the power of minus of 2000 t. This will be a current, but here the current direction will be opposite of this one. So we will get in this voltage equations, this current, actually the voltage is there, the current is flowing like that of the capacitor. Here the polarity is given as a reverse, that's why the current, actual current of the capacitor is plus of 15 e to power of minus 2000 t ampere, which one given in the option. Because this will be actually because of the polarity is given as this one is positive, this one negative, but actual current, actual voltage of this one will be positive negative because of this positive connected to the capacitor here, that's why due to the negative polarity the current calculation of the calculated current will be negative. Okay, this will be 15 e to power of minus 2000 t. Okay, simply in this case we have to find the initial voltage first, for initial voltage, then we have to find the final voltage at t equal to infinity, which one is a direct because of the open circuit, all the supply voltage is appears on the this capacitor. Then we have to simply apply the formula, final voltage plus initial voltage minus final voltage equal minus t by tau. According to this you will can find the voltage, and then we have to calculate the tau. Tau is really RC, you know about this one simply and calculate a time constant. Then after we apply the voltage, after the voltage we know about the current equation of the capacitor is c dvc by dt, then simply differentiate this one, then finally we get the current equations. Okay, next question of this is, consider a circuit shown below, switch has been in position 1, okay, initially at position 1 for a long time, and at t is equal to 0 switch is moved to position 2. After the long time period it will move to this one. Calculate the current IT, this current, asking about the current, this current IT. Okay, same phenomena we have to find first of all initial voltage, then final voltage. At initial voltage it means circuit at t is equal to 0 minus, at 0 minus you know this circuit connected to this one, this is the supply voltage, then resistor, Then second resistor capacitor is connected across this one, R2. This is 12 volt. R1 is 6 kilo ohm, and this is 100 microfarad, and R2 is given as 3 kilo ohm, and we have to find this current IT. At t is equal to infinity, 0 minus, this will be at steady state, and this will be open circuit. Then what is the voltage across it? Voltage across this resistor is same to connected to this one. That's why you have to calculate the voltage across this resistor. How can you calculate? This will be calculated by seeing these two resistors are connected in series combination. Because of this is the open circuit, no current is flowing through it. If the zero current is flowing through it, is that means the both resistors are connected in series. And simply you can apply the voltage divider rules. And same thing, this will be VC. Then VC 0 minus is same as VC 0 plus, which one equal to total voltage of 12 volt. Then resistor is 3 kilo ohm divided by of total resistor of 9 kilo ohm. Initial voltage of this circuit is 3 3 ja 9, and then 3 4 ja 12. This will be 4 volt. Then what is the circuit at t is equal to infinity? There is a no source. It means the same circuit is connected to this one, not this one. The circuit is looks like that. In this case, the source voltage will be open circuit, and second one terminal is connected. There is a no source, then you can directly return as V infinity will be 0 because of there is a no source. Then what is the Vt? You know about this will be infinity plus initial voltage minus of infinity final voltage into e to power of minus t by tau. Final voltage 0, initial voltage is 4 minus 0 e to power of minus t by tau. This will be 4 into e to power of minus t by tau. But we have to calculate the next time constant tau. Here is a more than one resistor, R equivalent into C. What is the R equivalent? We have to see from here. Then these two resistors are connected in parallel combination. Then we have to find the equivalent resistor. It means 3 kilo ohm and parallel to this will be 3 kilo ohm, this will be 6 kilo ohm into C. C will be a capacitor is 100 microfarad. 3 kilo ohm, 6 kilo ohm, you know about 3 into 6 divided by a 3 plus 6, 9 kilo ohm. It means 10 to power of 3 into 100 microfarad 10 to power of minus 6. This will be 2 into 10 to power of, this will be 302050 minus of 1. It means this will be 0.2 second. Vt is equal to 4 into e to power of minus 5t. Then you have to find the current, this one. You get the value of this voltage across the capacitor Vt. Then simply if you want to find the current, it means voltage divided by a resistor It. You can say this will be It, it will Vt divided by 3 kilo ohm R2. Vt calculated, then divided by R2, this will be 3 kilo ohm. Then It is equal to Vt divided by of R2, this will be 4 e to power of minus 5t divided by of 3 kilo ohm. With 3, this will be in milliampere, because of this 3 kilo ohm 10 to power of 3. You can say this will be 4 by 3 e to power of minus 5t milliampere. This much amount of current is flowing through the 3 kilo ohm resistor in the circuit. Okay, in this case, the on the question you can read that carefully. The current is asking at 3 kilo ohm resistor, not a current of the capacitor. If the current of the capacitor is asked, so simply you can apply I is equal to C dVc by dt. But in this case, you can't apply this one, because of the current is asking flowing through the R2, resistance of R2, which will be 3 kilo ohm resistor. Then first of all you have to find the voltage across the resistor, which will be same as the capacitor voltage. Once you got the capacitor voltage, then simply you can apply V by R for the current. Okay. In your exam, you can sort the step. There is no need for there is a objective type of question asking in the exam. Then there is no need to solve all step there. You have to simply sort this one. You can skip the step. Simply you have to find like that. Suppose same question. Oh, sorry. The same question is asking in your exam. Okay, I explain once this one. Suppose the same question is asking in the exam. The circuit is looks like that. This 12 volt, position 1 2, switch is called as T is equal to 0. This is 6 kilo ohm. Simply you have to check the connection of this one. What happening? If there is the connection is given as T is equal to 0, before 0 it will connect it to the source. It means there is a initial charge of the capacitor. If same thing as T is equal to 0 minus, there is a no there is a no source is there. Suppose there is a no source is connected to the capacitor and inductor, then there you can simply write the initial voltage and initial current will be 0 if there is a no source before the T is equal to 0. No need to draw a circuit for this one. Simply check that there is a circuit, a connection is there where is a source is available or not before the T is equal to 0. This means if T is equal to 0, voltage is available or a source is available, then you have to find T is initial voltage and initial current. If there is a no source, then simply we can write this 0. Same thing for the final voltage. We have to check this one as after T is equal to 0. This circuit is looks like that. This one. In this case, you can see there is a no source available, voltage or current. The source, it means voltage or current source. If there is a no voltage source, simply you can write the infinity. Final voltage is 0 or final current is 0. There is a no current at a steady state. It means the whole charge of the capacitor is discharged till the infinity time. Then no need to draw a circuit. If both the cases have some voltages or some sources given in the question, and that time we have to draw a circuit for both t is equal to t minus and t is equal to infinity, both. Then we will find the voltage, initial voltage, final voltage, then apply the formula. Okay, you know about the formula. T is equal to v infinity. You can modify this one also. If v infinity is 0, it means if there is no source after t is equal to 0, then if there is initial voltage, that one is only t is equal to tau. No need to find this formula also to apply this formula. If initial voltage is 0 but final voltage is there, something is there, then in that case, if the t is equal to after t is equal to 0, if after t is equal to 0 there is a source, some source is there, then that case infinity voltage 1 minus t by tau. Okay, it means this one is 0, initial voltage is 0, then you can common v infinity, this 2 is there. After t is equal to 0, there is a no source. After t greater than 0, if source is there, here is a no source at t less than 0. If t less than 0, no source, it means source is available after t is equal to 0, then you can directly use this formula. If no source is after t is equal to 0, simply you have to apply this formula. No need to check the all of things. Okay. This step save your time in your exam. Question number 3, like question number 3, the switch in the RL circuits one below is moved from position 1 to position 2 at is equal to 0. In this case, it's position 1 and this is position 2. Given as switch is moved from position 1 to 2. First of all, it connected to the 1, then after connected to the 2. It means at t is less than 0, there is a source, and after t is equal to 0, there is a no source. If after t is equal to 0, there is no source, it means the inductor, it means final current is 0. No need to check this one. No need to draw a circuit, full circuit. Simply there is no source, you can apply 0.
Sir,
Yes.
sir, can you show the previous slide?
Okay, 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 okay. This one, before this one.
Yes, sir. But what is the answer of the question?
Actually, this one is this one. This
4
is the
by
one.
3.
4 by 3 e to power of minus of 5t.
Okay, okay.
Yes. In this case, simply you can say the final current is 0. No need to draw a circuit of this. It means there is a source before the t is equal to 0. Then there is a need to draw a circuit and find the initial current of the inductor. Then what is the initial current of this inductor? At t is equal to 0 minus, then this inductor behave like a short circuit. What is the current of IL in this case? This is 2 ampere current, 100 ohm of resistor. This is the VR, this is the VR. The whole 2 ampere current is flowing through this. It means the initial current of the inductor is 2 ampere, because of IL at 0 minus is same as IL at 0 plus, because there is no sudden change in the inductor current and capacitor voltage. This will be a 2 ampere. Initial voltage, initial current is there, final current is 0 because there is no source. Then what is the current? In that case, IL is equal to same, there is if it current 0, then simply you can apply initial current e to power of minus t by tau. What is 2 ampere e to power of minus t by tau? What is the tau? There is only two component, inductor and resistor. Tau know about, this will be L by R. Inductor is 4 Henry, resistor is 100 ohm. This will be 1 by 25. You can put the value here, 2 into e to power of minus t divided by 1 by 25. Then IL is equal to 2 into e to power of minus 25t. This is ampere. Okay. But in the question is asking about the value of inductor voltage, not the inductor current. Then you have to write the question carefully. First of all, what the asking in the question, current or voltage of the inductor or capacitor or another resistor is there also. Then you have to find like that. Then in this step type we have to draw circuit at t greater than 0. What is circuit? Then after you can see the voltage. After this one, up t is equal to 0, this circuit is connected like that. There is a resistor and a capacitor. This circuit is connected like that. Okay. This is the 100 ohm resistor. This is 4 Henry inductor. Then there is a initial current. Initial current of 2 ampere. In the case of inductor, the initial current is right like that, parallel to the inductor, not a series combination. A voltage source of the initial voltage source of the capacitor is writing in the series of the capacitor. But in the case of inductor, the initial current is right parallel to the across to the inductor current. Inductor. Okay. This the type of circuit is there after t is equal to 0. Then you have to find the voltage of the inductor. It means this voltage. VL, and the current is flowing like that. The direction is there, then current is flowing like that. Okay, then you can say this is the positive, this is the negative, VR is there. Then what is the VL? You can say the VL is equal to positive connected to the negative, it means there is a negative of VR. And what is the voltage across the resistor into current? Then same this 2 ampere current flowing through it. But in this case initial current is 2 ampere, but the actual current flowing through it is 2 into e to power of minus 25. This is the initial current. Now, because of that initial, you can put the value of 0, it is equal to 0, 2 ampere. At infinity, put the value of infinity, this will be 0. That's why this will be written as ILT, which one is 2 into e to power of minus 25t. Minus of 100 ohm resistor, and this will be a 2 into e to power of minus 25t. This is the minus of 200 e to power of minus 25t volt. This is the inductor voltage after t is equal to 0. Inductor current is 2 into e to power minus 25t. For this simple circuit, if you confuse that, simply you can apply the voltage VL. You know about this one, L di by dt. Voltage of the inductor is L di by dt. Inductor is 4 Henry and current is this one, current 2 into e to power of minus 25t. You can apply, this will be 4 into 2 is 8, differentiation of this one is minus 25 into this will be same differentiation minus of 200 e to power of minus 25t. In both conditions this will be the same. If you know about the circuit, proper circuit, if you draw proper circuit, then you can apply both formula. Both are the same. But if there is any other circuit is also present, some other component which only connected across the inductor or another circuit, then you can apply this type of formula. This is the general theory, general formula of IR. You know about this one, and this is the voltage of the inductor L di by dt. Okay. Let's go for the next question. Yeah. The switch in the figure has been open for a long time, and before it closes at t is equal to 0. Okay, the current IT, where current, this is the current IT at time t after the switch is closed. At time t, it means simply at t greater than 0. You have to find the current, this current. But here dependent source is there, then you have to carefully handle the dependent source. In this case, you can find the initial voltage and final voltage, but that at the time of the finding the time constant of your circuit is different thing. There are two resistor and one inductor. If there is no dependent source, then you can simply find the resistor, find the value of the resistor equivalent resistance. But there is a dependent source, then that dependent source also impact on the passive component, which will be the resistor. Okay, let's go for solving this question. Suppose circuit at is equal to 0 minus. What is the circuit? This circuit is not close to this one. Even this is the open circuit. Only this circuit is there. There is a voltage source. Which one is the 18 volt? Then a 6 ohm resistor is there. A 3 ohm resistor is there. At is equal to 0 minus, the inductor will be short circuit. 12 Henry. This is the current IT. And the another circuit which is not connected to in here. This will plus minus up to Ix. And Ix is given in the question is this one. This current is Ix. In this case, we have to find the value of 0 minus current. And you know about the I 0 at inductor current 0 minus is same as inductor current at 0 plus. What is the current of this one? Both are connected in series and after the connected to the voltage source, and simply you can apply voltage source divided by total resistor. 6 plus 9 6 plus 3 is 9, which will be a 2 ampere. Initial current of the inductor is 2 ampere. Then we have to find the final current. What is the final current? We have to find the circuit at t is equal to infinity. Sorry, is equal to infinity plus minus again resistor, and this circuit is close to that dependent source, and this will be a 2 Ix. Ix is this current, and then after a resistor, and again the inductor current is short circuit at infinity. Then we have to find this current at infinity. 3 ohm, this is a 6 ohm, this is a 18 volt. this current is Ix, then same current is leaving from here, Ix also. Okay, this current is I infinity, same entering current is I infinity. Both current is passing, but there is a voltage source. This direction current of this one is plus and minus. You can apply loop 1 KVL. KVL at loop 1. I started from the here. This will be minus first, minus up to Ix, then after plus 6, current is Ix, plus this will be 18, which one equal to, after that the closed circuit will be voltage is 0. This will be 4 Ix plus 18 is equal to 0. Then 4 Ix is equal to minus of 18. Then what is the Ix? 18 divided by 4, 4 4 ja 16.45 is minus of 4.5 ampere. Okay, Ix is there. This is the minus 4.5 into 2 is minus of 9 volt. Minus of 9, so is that this is given as a polarity is minus, this is plus, but actually is a minus of 9. It means this is the positive and this is the negative. Oh, sorry, this will be negative reverse. This is the negative and this is the positive. Then this positive connected to this one, negative connected to this one. It means current should be flowing like that, but the actual current is this one, I infinity. What is the I infinity in this case? I infinity is this voltage 2Ix. You can see this 2Ix is simply applied to this resistor. Okay, 2Ix divided by of this resistance 3 ohm. 2 into Ix is minus 4.5 divided by of 3, minus of 9 by 3, which will equal to minus of 3 ampere. This you can say the final current is minus of 3 ampere. Initial current already calculated. This will be a 2 ampere. This is the 2 ampere. Then what is the current equation? IT. Final current plus initial current minus of final current, then e to power of minus t by tau. What is the final current is minus of 3 ampere. Initial current is 2 ampere minus of 3 e to power of minus t by tau. This will be a minus 3 plus 5 e to power of minus t by tau. Then we have to find the time constant tau. I write the it minus of 3 plus 5 e to power of minus t by tau. But what is the tau? Know about the RC. There is only once RL. Sorry. In the case of RL circuit, this will be R divided by L by R. There is a single inductor, but resistance is different. Then this will be R equivalent. Then we have to find the R equivalent in this circuit. How can you find? There is a dependent source. Here is the dependent source. If dependent source is present, That case you have to find R equivalent. It means same thing, Thevenin equivalent resistance. For the Thevenin equivalent with dependent source, you know, or simply apply the VI method. For dependent source, but apply VI method, and simply you can remove this inductor and apply a voltage and a current across it. Okay, because of you have to find the R equivalent at this one from the inductor side. Then what the circuit? This is voltage, this is current, 3 ohm, 6 ohm, this is 18 volt plus minus up to Ix, and this is the Ix. Okay, this current is I. In this loop you have already calculated Ix. Simply you can apply loop 1 KVL, and then after loop 2. There is no change because of the voltage source. You can simply, but you can apply this is minus of 2x to Ix plus of 6Ix plus of 18 divided equal to 0. This will be a 4Ix is equal to minus of 18. You know about the Ix is equal to minus 4.5. Okay, there is 4.5 and this will be minus of 9 volt. Already we have calculated. Okay, then KVL in loops 2, and second loop simply apply minus of V from here plus 3I plus 2Ix is equal to 0. Then you can say V is equal to 3I plus 2Ix. V is equal to 3I, 2Ix, it means minus of 9, 1.5 into 2, minus of 9. You can say this is equation number 1. There is no equation. Where this denoted as the RTH and this is denoted at VTH. There is no need of VTH actually. Then you can say R equivalent is equal to RTH is equal to 3 ohm, and inductor is given in the question 12 Henry. Then what is the tau? L by R. L is 12, R is 3. This will be a 4 second. Then what is the actual current? This is the 4 second. IT is equal to minus of 3 plus of 5 e to power of minus t by 4. IT is equal to minus of 3 plus 5 e to power of minus 0.25 t ampere. This is the final current. This question is asking this current minus of 3 plus 5 e to power of minus 2t 2 minus 0.25 t. I think option 1 is correct. Okay. There, if there is the dependent source is there in this question, any question, if that time you have to calculate the R equivalent carefully, because of the dependent source also add some resistance. This one is affected to the resistor. If there is no dependent source, or simply you can short circuit the voltage source and open circuit the current source and find the R equivalent. But in this question, there is here is the dependent source. Then first follow find the both initial current, then after final current, then we have to find the tau after t is equal to 0, taken the circuit after t equal to 0, then find the R equivalent, and L by R is the time constant for the inductor case and RC is the time constant for the capacitor case. Okay, next go for the next question. In the circuit shown below, switch is moved to position 2 at t is equal to 0. It means first of all is to be connected to position 1, after that t is equal to 0 is connected to position 2. The value of current I2, where is I2? I2 is current flowing through the 10 Henry of inductor. I2 at t is equal to 34.7 millisecond. Okay. Before t is equal to 0, the switch is connected to position 1. It means the current is simply connected to the all current flowing through the 10 by 6 Henry of inductor. It means there is some current, initial current. This is the open circuit. It means the whole current is flowing through like that, and the current direction is this one. Okay, let's try for t at t is equal to 0 minus. After t is equal to 0, you can see there is no source. If there is no source, it means that t is equal to infinity, inductor current will be 0. No need to check the circuit, simply no need to draw a circuit. So, no need to draw a circuit, simply you can write the 0 because of there is no source available after t is equal to 0. But before t is equal to 0, there is a source. That source is connected like that. The direction of the current is same as before the 0, after the 0. You can't change the direction of the current because of the current across the through the inductor is not sudden change. The circuit looks like that. In your exam, there is no need to draw all the circuit. It will take the time. There is no need. If you understand without drawing the circuit, then simply you can write the value. The 6 ampere current is flowing like that. At t is equal to infinity, all the inductor will be a short circuited. Okay. The short circuit, there is no meaning of these two inductor. All the current passing through it is zero. Only this current is there. IL 0 minus is equal to 6 ampere. Then you can write minus is same as IL 0 plus is equal to 6 ampere. This current is 0, no need to check. I2 also 0. You take this is I1, then I1 0 plus is ISO 0. Because why 0? Because there is no source available in this portion of the circuit. There is no source, it means current is 0. But here is source is available, that means the IL is 6 ampere. Okay. What is the final current? You know there is no source after the t is equal to 0. This same circuit is connected like that. Then of the all the in this case there is no source available. If there is no source available, then directly you can write IL infinity is equal to 0. And what is the value of IL? So IL into t infinity plus IL 0 minus IL infinity e to power of minus t by tau. Infinity 0 plus 6 minus 0 e to power of minus t by tau 6 e to power of minus t by tau. Question number first. Okay. Then we have to calculate the tau. How can you calculate the tau? There is more than one inductor. Resistors is only one. Then we have to find the inductor equivalent from seeing from the this resistor. Then what is the circuit? The whole circuit is looks like that. There is no need to draw this one. Whole circuit is this one after t is equal to 0. This inductor, is a some resistor is there. No need to draw resistor because you have to find the inductor equivalent seen from this resistor. This is the 10 by 6 Henry. This is the 5 Henry and this is the 10 Henry. These two are connected in parallel. Then after this circuit is closed like this one, a series combination. Simply I write here L equivalent seeing from this one. What is the parallel combination of these two? 5 into 10 divided by of 5 plus 10. 10 by 3. 50 divided by 15. 5 10 are 15. 5 3 are 15. This will be a 10 by 3. Now you can see these two are connected in series. Then what is the L equivalent? Simply you can add these two. 10 by 6 Henry plus 10 by 3 Henry. 6 as the LCM, 10 plus 20, this will be 30 by 6 is 5 Henry. Okay, then what is the tau? Tau simply L by R, has L equivalent in this case 5 divided by a resistor. Resistor is 200 ohm, 1 by 40 second. You can put the value of tau here. Then what is the IT? IT is equal to 6 into e to power of minus t by tau. Tau is 1 by 40. Then IT is equal to 6 e to power minus of 40t. Okay. Then after there is a circuit asking the current cross this through this inductor. Okay. Let's draw a circuit for this one. Find the final current of I2. Because in the question asking this current, not this current. We have found the value of this current. After t is equal to 0, the circuit, whole circuit is looks like that. And there is a current source. Initially, our current source is 6 e to power of minus 40t, 200 ohm of resistor. Inductor is 5 Henry. This is the 10 Henry. This is the I2. Oh, sorry, the direction is above because of the current is flowing like that, above direction. Then we have to put this direction. Okay, this same current is flowing through this one also. This current is 6 e to power of minus 40t. Then after this is divided into two part, because of both are connected in parallel, then simply you can apply the I2 current divider rule. What the current divider in the inductor and resistor both have are the same as current divider. That is 5 Henry, 10 Henry. Then we have to apply the opposite of this one, 5 into first of all the total current is 6 e to power of minus 40t into the opposite inductor is 5 divided by of total 5 plus 10. 5 3 are 15, 3 2 are 6. Then I2 is equal to 2 e to power of minus 40t is the answer of this question. But so in the question is that given tricky also asking the current at t is equal to 34.7 millisecond. You have to put the value of t is 34.7 millisecond here. I2 at 34.7 millisecond, 2 into e to power of minus 40 into 34.7 millisecond into 10 to power of minus 3. 40 into 34.7, so is equal to 1388 into 10 to power of minus 3. This will be 2 e to power of minus 1.388 I2 34.7 milli is equal to 0.499 is approximate is equal to 0.5 ampere. Or we have to calculate the value of this like that. How can we calculate? Simply in the question is asking the given circuit below switch is moved to position 2 at is equal to 0, the value of current I2, which one is flowing through the 10 Henry of inductor here at t is equal to 34.7 millisecond. Then before this one putting the value of time t, you have to find the first of all the current equation of I2. For I2 there is no source, no impedance independent source is connected to the I2 inductor. That means there is no source. Then how can you find? First of all you have to find the current, initial current of that inductor which one connected to directly source. In this case 10 by 6 Henry inductor is connected to the source. Then you have to find first of all this equation, this current equation. Initial current, you can simply, if you put the circuit is here, then to know about this one, initial current is simply 6 ampere. Total current is flowing through it because of there is no, this is dead circuit, no current is flowing through it in this case because of no source. All current is 0, 6 ampere. After t is equal to 0, there is a no source. After t is equal to 0, no source, it means this current also 0. This current is also 0, infinity also 0. Then only is this one is current. What is the IT in this that case? You know about the initial, only initial is there, that remains 6 e power minus t by tau. You can write this thing, only this thing in your paper because of there is a objective type of question in your paper final exam. Then there is no need to draw this circuit and all calculation, no need of this one. Simply you know, in this case there is a, this is the open because of the no source, only this is connected to that one. Then it means the whole current flowing through it before 0, it means initial current is 6 ampere. Final current is this switch is moved to this one, this sorry, source is disconnected, it means this current is also 0. Then what is the current? 6 initial current into e to power minus t by tau. Okay. Then this current is initial t by tau. We find the this current. Okay. Then after we have to find a tau. Tau we know about only one resistor, R is fine. Then after this one we have to find these two equivalent inductor, these two are connected in parallel. Then after the series, if there is a confusion, then you can draw the circuit for finding the L equivalent. Then after you can say the time constant. After that, if the current is fine, parallel current, then simply you have to draw a circuit, and this current is same current is flowing through these two, and these two are, this current is divided into two part, 5 Henry and 10 Henry, and then you can find the I2. Okay. After this, you simply you can put the value of t. Next question is here. A series RL circuit has constant voltage V applied at t is equal to 0. At what time does VR is equal to VL happens? The series RL circuit and a constant voltage, it means the DC source is applied at t is equal to 0. It means before t is equal to 0, there is no source. It means there is no initial voltage, initial current, sorry, initial current in inductor case. In this case, simply you have to draw a circuit, RLs, a resistor, and a inductor connected in series. Then after it will connected across voltage C applied at t is equal to 0. It means a voltage source V applied by a switch. The switch is closed at t is equal to 0. This is R L. And voltage, what is the voltage of this one? VR. This is the VR. Suppose current is flowing as IL. Yeah. This is the circuit. Then in the circuit is asking about the what time does the VR is equal to VL. VR is equal to VL. It means half of, if the VR and VL is equal, it means both are V by 2, V by 2, half of the voltage applied to those. Then first of all, we have to find the current. Then after we find the voltage across the inductor, which one is the same as the VR, IL into R. Okay, let's try. Initial current, simply there is no voltage source. Then you can say the initial current of this is 0, and final current, this is short circuit. Right here at t is equal to infinity. Inductor will be short circuited at a steady state. B, this will be R, IL at infinity. What is this current? Is same V by R only. Initial current is 0. Then what is the IL? IL infinity plus IL 0 minus IL infinity e to power of minus t by tau. Tau is simply RL circuit, R L by R. Infinity is V by R plus 0 minus V by R e to power of minus t by tau. ILT is equal to V by R into 1 minus e to power of minus t by tau. Okay. Tau in this case simply RL circuit, then R by R. We need to check another thing. You know about the VR, voltage across resistor, I into R. Which one is equal to R is R into V by R 1 minus e to power of minus t by tau. And V into 1 minus e to power minus t by tau. Here tau is L by R. This will be a R by L into T. R by L into T. Okay. And VL, you know about the voltage across the inductor, L di by dt. This will be equal to L into dy dt of V by R 1 minus e to power of minus R by L into T. Differentiation of this one, V by also can common. Differentiation of 1 is 0 minus differentiation of e power minus something is, this will be minus R by L into, this will be a same e to power of minus R by L into T. VL is equal to L into V by R into, this will be R by L into e to power of minus R by L into T. VL is equal to L cancel out, R cancel out, V into e to power of minus R by L into T. This question is given as VL, what at time? VL is equal to VR. VL is equal to VR. We have to calculate this one. VL is V into e to power of minus R by L into T. VR is equal to V into 1 minus e to power of V 1 minus e to power of minus R by L into T. V cancel out, e to power of minus R by L into T is equal to 1 minus e to power of minus R by L into T. This will transfer to the left hand side. This will be a 2 e to power of minus R by L into T is equal to 1. Then e to power of minus R by L into T is equal to 1 by 2, which was 0.5. R by L, you know about this will tau. E to power of minus R by L is T by tau is equal to 0.5. You can apply the log ln. You apply ln e to power of minus T by tau is equal to ln 0.5. This will be a minus T by tau is equal to 0.5. Ln 0.5 is equal to 0.693. What time? Time is equal to 0.693 time constant tau. At this time, the VL is equal to VR. Both are same. Inductor voltage and resistor voltage is same at this time. Okay. In RL circuit, simply we have to find the inductor current, then after we have to find voltage L di by dt, then apply this one VL is equal to VR. Consider a circuit as shown in figure below. The capacitor voltage at t is equal to 0 minus just before the switch is closed. In this case, simply you have to draw a circuit before t is equal to 0. In circuit at t is equal to 0 minus. It means this is open circuit. This is not connected. This connected at t is equal to 0. But you have to find the value before this will connect it. Now what is the circuit? This is the voltage source or resistor, and this inductor before it is so in a steady state this will be short circuited, and resistor, this is the open circuit voltage of 12 volt. This is 2 ohm. This is open circuit, switch is not connected, 1 Henry, 2 farad. What is the voltage across this? Anyone can guess the voltage across the capacitor? Okay, this is the open circuit. It means there is no current. Current is zero in this branch. It means whole current is passing through it only. This current is zero, 12 volt. Okay, you can see this is open circuit. There is no current. It means no voltage drop here, and these 2 points are connected to this circuit, and this 2 point is short circuited. This point is short circuited. It means the voltage across this is zero. The voltage is zero. It means the same voltage occurs at this capacitor. It means the at V is equal to 0 minus the capacitor voltage is 0. Okay, it means A option. There is all options there. If open circuit voltage, you can directly take the voltage 12 volt. This is the wrong answer. If you want to find the voltage across this resistor is same as this thing, this voltage, then what is the voltage across this resistor is 12 into 4 divided by 6, it means 8. This is also common given in the option. Then we have to do this one carefully. The all option can matched. Okay, Their question, in the following circuit VC, but I mean initial voltage is given as 5 volt and the VC at 5 at t is equal to zero point 0.1 second, it will be 5 by E volt. Then the value of capacitor, asking the question. In the following circuit, the initial voltage is already given, then no need to calculate the initial voltage. And if the initial voltage is given, what is the final voltage? There is no source available in the circuit, then final voltage is 0. No need to calculate. Initial voltage is 5 given the question. Final voltage no need to calculate because of there is no source. This will be 0. Then what is the Vt? Vt is simply 5 e to power minus t by tau. Tau is Rc, 5 e to power of minus t by R into C. I simply write tau and tau is equal to Rc. Okay. Vt is there. In the question is given at Vc at 0.1 second 5 by E at t is equal to 0.1 second. What happening? Vt is equal to 5 e to power of minus t by tau. Vt at 0.1 second 5 by E. Then this circuit is 5 e to power of minus 0.1 by tau is equal to 5 by E. 5 will be cancelled out. E to power of minus 0.1 tau is equal to 1 by E. You can multiply here or you simply you can say this is e power minus of 1. 1 by E you can write e power minus 1. If you can write this thing, that means both base are same, then you can equal the value of power. Minus 0.1 tau is equal to minus of 1. Minus minus is cancel out. 0.1 is equal to tau. If tau is given 0.1, what is the tau? Tau is Rc. Rc is 0.1. What is the capacitor C? 0.1 divided by of R. R is given in the question is 40 kilo ohm. 40 into 10 to power of minus 3. Oh, sorry, kilo ohm. Positive, this is not negative. This will be 0.1 divided by of 4 into 10 to power of 4, or you can say 0.1 divided by 4 into 10 to power of minus 4, or you can say this will be a 10 if you multiply by 100 here. 10 divided by 4 into 10 to power of minus 6, and C is equal to 2.5. 10 to power of minus 6 is microfarad. 2.5 into 2.5 microfarad. Okay, the simple thing is given as initial voltage is already given. Final voltage is 0 because of there is no source after t is equal to 0. If there is no source, simply you can apply the voltage equation, which will be initial voltage into e to power minus t by tau, and put the value of voltage at t is equal to 0.1 second. this will looks like that. Same thing you can say this is e power of 0.1 tau is equal to 1 by e. You can multiply of e 0.1 by tau into e is equal to 1. If you multiply this one, it means e to power of 1 minus 0.1 divided by tau. Because of this power is 1, in multiplication of power will be added, then minus of 0.1 by tau add with plus 1, this is 1 minus it. You can apply ln log, apply ln e to power of 1 minus 0.1 0.1 tau is equal to ln 1 log 1 is 0 0, this will be 1 minus 0.1 by tau is equal to 0. That means in this case tau is equal to same as 0.1. Same thing here. Okay. Okay class, I want to stop here for the today class, and next class is extra class, it will be happen at 9. It means day after tomorrow at 9th of October. Extra class 9th of October is there. I taught the Laplace theorem is there, so how to apply the Laplace in your network theory. Okay, this thing is I stopped here, stopping here. Next class is same as 9th October, same timing, 7 to 9. Okay, thanks to attend this one. Thanks to all.